All right, let's see if this works. All right, students, welcome back. I'm going to show you how to do some balancing chemical equations. So let's get started. So the questions that I'm looking at are the checking comprehension questions that were posted on the video that I linked to on Schoology last week. It should be called Professor Dave Explains, and it's balancing chemical equations. I'm looking at the checking comprehension questions at 325 into that video. So if you go to the 325 mark and pause it, I'm going to go through each one of those questions individually, one by one, to show you how they're done. So let's get started. For number one, we have phosphorus plus oxygen yields, we have 4 phosphorus and 10 oxygen. Right. So first things first, to solve one of these equations, what you're going to do is you're going to make a T-chart. So on the left-hand side, you have the reactants. On the right-hand side, you have the products. So the reactants are the things that react. The products are what you get after the fact. And remember, product is the result of a multiplication problem. So you kind of think of it in that way. So we have reactants on the left and products on the right. And then what we want to do is we want to see which elements we have. And we only have 2 of them. They are potassium and oxygen. The next thing we're going to do is we're going to count how many of each element we have on either side. So for the left side, on the reactant side, we only have 1 potassium, but we have 2 oxygen. And on the other side, on the product side, we have 4 potassium and we have 10 oxygen. All right, so here's what we do next. We want to look and see on our T-chart how many we have of each element on each side. Because the whole point of this is that in our universe, at least, no matter can be created or destroyed. So that means that whenever we have a chemical reaction, the same amount of stuff that we have reacting will always be the amount of stuff that we have after the reaction. The difference is it's going to be in a different chemical structure after the reaction than it is beforehand. So we want to see how much of each element we need to make this reaction happen. So we need to balance each side of the chemical equation, and there's one way that we can do that. We can do that by doing, we could place these numbers in front of each spot right here. These are the only places where you can put numbers, and the numbers that you put there are called coefficients. Now, what coefficients do, coefficients tell you how many of that atom or molecule there are. So this is O2. It's just a molecule of 2 oxygen. I need to make sure I have the right number of those oxygen molecules so that after the reaction we have the same amount. So we have 2 to begin with and we have 10 after, so that obviously doesn't work. We need a 10 over here, and we need to find a number times 2 that will give us 10. So that's obviously 5. I'm going to switch pens here really quick. And I'm going to put a coefficient of 5 in front of this oxygen. Now this is telling me I have 5 oxygen molecules. So it's 5 times 2 atoms of oxygen, which gives us 10. So now we're even on both sides for that. So that's good. And then we have 4 over here on the product side, and we have 1 over here on the reactant side of phosphorus. So we're going to erase this, and we need to find a number times 1 that will give us 4. That's obviously 4. And now this is a balanced chemical equation. And how I know is that I can go count how many of each things that we have on either side, and also on our T-chart, they should be equal on both sides. So when you're looking at this, go back to check your answers. Go back and check how many of each element that you have. This is very important, especially for when we do problems that are a little bit more complex. It might take a little bit more effort to count all those because sometimes you'll have the same element in different parts of the problem, but I digress. So we have 4 phosphorus on either side. That's good. Then we have 10 oxygen here, that's good. And we have 10 oxygen there, that's good. These two are equal, these two are equal. That means all of this is balanced. Woohoo! Number 1 done. All right. Let me just make sure this is recording okay. Looks all right. Okay, on to number 2. Let me just erase this, put my cap back on. All right. Let's do number 2. Number 2 says AgF plus C. Oh, I want to leave a little bit of space in case I have to write there. So that's another thing. As you're doing these, make sure you give yourself space to put the coefficients. And also, if you're doing this with a pencil, you might have to erase a few times. Try not to write too dark so it ends up staying a little bit neater. So I'm going to leave a little space. Gives us AgCl plus CaF2. Let me just make sure I wrote that down correctly. Oh, and that's another thing. Whenever you're doing these, always make sure you wrote it down correctly, because if you do it incorrectly, number 1, you're talking about a molecule or element that you weren't dealing with in reality. So, I mean, the whole thing's going to be wrong if you write it down wrong. It's like the same in math. If you're trying to do a multiplication problem and you write down the wrong number, you aren't going to get the right result. Same thing applies here. So be very careful. Otherwise, you're kind of wasting your time. So we're going to make a T-chart again. I'm going to put it right beneath that arrow sign. So we have reactants and products. And then we're going to figure out what our elements are. And in this problem, there are a lot more elements than last time. So you got silver, fluorine, calcium, and chlorine. So just write those down to the left so you can have a little space here to write for your reactants. Okay, I'm going to change colors here in a minute once we start making changes. So we're going to count how many of each element we have on either side. For silver, we've got 1. For fluorine, we've got 1. For calcium, we got 1. For chlorine, we got 2 on the reactant side. For the product side, the products, we got 1 silver, 1 chlorine, 1 calcium. Whoops, be careful. I'm going to start over again because I was being careless. I need to go in order that I'm saying these. Silver, 1. Chlorine, 1. Calcium, 1. Fluorine, 2. And that's a testament. Learn from the mistake that I just made. Don't be careless. You have to make every step deliberate, and you have to make it correct. All right. So when I look at these, I see that there are some imbalances, like the fluorine and what's the other one? The chlorine are off. So I have 2 fluorine over here. That means I have to multiply this one by 2. So, because 2 times 1 gives me 2, I know I'm going to be messing with both of those. So I'm going to write my coefficient in, and then I'm altering the number of silver and I'm altering the number of fluorine, because this is all one molecule right here. So I'm going to cross both of those out and I'm going to recount how many of them I have. So I have 2 silver and 2 fluorine. Okay, that means that there are some different mismatches now. Fluorine's all good, but the silver is all out of whack. And that's to be expected. I expect that to happen because I know that I'm going to have to make a few steps along the way. Most of these problems are not just a single step. You have to do a few different steps to make sure they're balanced. And as long as you keep doing the process right, don't second guess yourself. You're just going to make some silly mistakes. If you adjust one thing and it changes another, that's totally normal. So for silver and chlorine, I'm going to put a 2 there because I know I need 2 silver on this side, and silver is only in this compound right here. So I'm going to put a coefficient of 2 right there. I'm changing the number. It affects both of these. So remember, you distribute that to each of the elements. So that's silver and chlorine. So now I have 2 silver and I have 2 chlorine. Oh, and also this one, you could think of it as like distribution if you've ever done anything with parentheses or something like that. So let's see if we're all balanced here. We have 2 silver, 2 silver, 2 fluorine, 2 fluorine, 1 calcium, 2 chlorine, 2 chlorine. Let's count them up again. 2 silver, 2 fluorine, good. 1 calcium, 2 chlorine. Remember, when you have a subscript, it only applies to the element that comes immediately before it. So if there's a subscript 2 right here, it only affects the chlorine. It doesn't affect the calcium at all. So be careful with that. And then we have 2 silver over here, 2 chlorine over here, good. 1 calcium, good. 2 fluorine, awesome. That is balanced. All right. Let's see. I'll do another one. Let's do a harder one together. Let's do number 4. Number 4 looks tough, so we'll try that one together. I'm going to make sure I'm recording all right, make sure I'm not going out of frame. I might have for that last one, huh? Oh, well, we'll see. For number 4, I'm skipping number 3. You could do that on your own. That one has 2 major steps in it. But let's do number 4. So this is H3PO4 plus KOH gives us K3PO4 plus H2O. Hey, we know H2O, that's water. All right, cool. So for this one, we're going to do a T-chart again. We have reactants, we have products. This one is tricky for a few reasons. The first reason is that you've got the same element in 2 different compounds, right? So I'm going to make that a little bit neater. So that's where it's going to get tricky. And you have to remember, whenever you count all of your elements, you're counting all of them for the entire reactant side and for the entire product side. So you need to remember that you have to count all of them for each side. Otherwise, you're going to make some silly errors that'll frustrate you for sure. So let's take a look at the different elements that we have on either side. So when you're doing this, you want to make sure that you only write down each element once on the left-hand side, because remember, we're counting all of them combined for the reactant side. We're counting all of them combined for the product side. So we have hydrogen, and it's in 2 elements. Then we have phosphorus. Then we have oxygen. And then we have potassium. HPOK. Yeah, that looks right. So now we're going to count how many of each element we have on each side. So we have 3 hydrogen there, and we have 1 hydrogen there. Let's count hydrogen over here, only 2. Phosphorus, 1. Phosphorus, 1. Okay. Oxygen, 5. 1 plus 4. You have to be very careful there. Otherwise, you're going to make a silly error, and I don't want to see that happen to you. It's too frustrating. We have 5 oxygen over here. Potassium, we have 1. Potassium, we have 3. So when I look at this, I would know I want to balance the potassiums first. And the reason why I'm saying that is because I know that if I mess with potassium, I'm also messing with oxygen and hydrogen, and I need to get more of that anyway. So let's give that a try. Let's mess with potassium first. I'm going to switch pens here so I can show you all the changes I'm making. All right, so if I have 3 potassium over here and I have 1 over here, I need to know I put a coefficient of 3 right here. This is going to affect the potassium, it's going to affect the oxygen, it's going to affect the hydrogen. So remember, you have to change all 3 of those. So we're doing potassium, oxygen, hydrogen. I'm going to recount all of those on that side so I know that I have my numbers correct. 3 plus 3 is 6, because remember, that's distributed over there. Oxygen, 4, 5, 6, 7. And then hopefully we have 3 potassium, because that was the whole point. All right. Okay. Let's see what we do next. So we have 4 over here. 5. Let's look at our hydrogen. 2 and 6. So I need to know, I need to put a 3 here, because 3 times 2 is 6, which means I'd have the same hydrogen on either side. So that's what I'm going to do. I'm going to put a coefficient of 3 here. Let's recount that. It's going to affect the hydrogen, it's going to affect the oxygen. 3 times 2 is 6. And then we have to count all of the oxygen on the whole side. So it affects this, it affects that. We have 4 oxygen right here, plus 3 oxygen right here. Would you look at that? It is balanced. And here's how I know. I have 6 hydrogen over here. 3, and then we have 6. We have 1 phosphorus. We have 7 oxygen. So we have 4, 5, 6, 7, right? And then we have 3 potassium. 3. Cool. 3 potassium. How many phosphorus? 1. Let's count all the hydrogen. 3 times 2 is 6. Nice. And then for oxygen, let's count all of that. We have 4 right there, plus 3, which gives us 7. All of these check out, which means that this one is balanced. All right. So let's see how you guys do on the rest of them. I will be doing some sort of Q&A live stream later today. I will let you know when I go live. Stay tuned on Schoology. I'm going to upload this video, and depending on how long that takes is how long I do the live stream. Maybe I'll do it tomorrow morning. I don't know. But anyway, hopefully you have an idea about how to start balancing these. I'm going to have you guys try to do all the checking comprehension questions on Professor Dave's video. I will post a screenshot of that so you know which problems to do. Try doing them on your own. If you have any issues with them, I will give you an opportunity to respond in a video chat that we'll do. So look forward to that. I'm trying to get all this teaching from home stuff under my belt. I'm not very experienced, obviously, in teaching this stuff over, the internet. I miss being in class with you guys. So this is the next best thing. So I'm going to give it a shot and see you guys later. Hopefully it's not too frustrating. And if it is, let me know so I can help you. All right. Thank you, students. See you soon.